Hi, I'm Rana. I'm studying an integrated Masters for Pharmacology and Drug Discovery. In the lab this summer, I've been investigating chemoresistance in cancer. Now, chemoresistance is when cancer cells are able to resist therapy treatments. This is the cause of about 90% of cancer deaths due to patient relapse. Now, what we've been investigating is developing drug leads to prevent this from happening, as it's quite a prevalent and serious cause that we'd like to prevent. We've been looking at controlling protein-protein interactions, specifically between NRF2 and MAFG. Now, NRF2 is a transcription factor. That means that it's able to control genes by turning them on and off by binding to DNA. Now, NRF2 normally has the role of reducing inflammation in the body. However, when it's overexpressed in cancer, meaning that the cancer cell has a mutation that creates too many copies of NRF2, it produces proteins that lead to chemoresistance. So when NRF2 binds to MAFG, it traps this complex in the nucleus. So NRF2 is still able to bind to the genes and create all these proteins that cause chemoresistance. What we're looking at is synthesizing mimics of the MAFG peptide that are still able to bind to NRF2, but will allow the complex to leave the nucleus. So NRF2 is unable to keep causing the genes to form these proteins that cause chemoresistance. And that's what I've been working on in the lab so far. In my time in the lab, I've synthesized around 8 different mimics of the MAFG peptide. Each one of these peptide mimics has a different structure. This will allow us to push the drug design process forward, as some of them may be able to bind to NRF2 more strongly, some of them might be able to bind to NRF2 for longer. So by investigating this, we'll be able to see which ones are the best to create drugs. Another machine I've used is the circular dichromatin machine, and that measures the alpha helicity of the peptides. Now, the peptide MAFG, usually when it binds to NRF2, they form these coiled coils, and the alpha helicity is how coiled it is. What we found is the peptides that we've synthesized have this alpha helical formation before they've bound to NRF2. So what I've looked at is the percent of alpha helicity. So the different structures of the peptides, some of them will stay coiled for longer. The thing is, with our peptide, MAFG, normally it's not in a coiled formation until it binds with NRF2. But what we found with our peptides is that they are coiled before they bind. So this could lead to faster binding, or some of them will bind for longer. Also, obviously, these are more ideal in drug synthesis, as if we have a peptide that can bind for longer, it can act for longer as a drug. This is a research that will be continued by the lab group that I'm working with, as I didn't have time to investigate the cellular aspects of the project. But this is what real cancer research is like. It's long, it can take years, but I will be following the field to see where it goes, and I'm quite excited to see what developments will be made. What's exciting about this research is that it's not relevant to a specific type of cancer, as chemoresistance could occur in many different types of cancers, such as advanced ovarian cancer or types of leukemias, for example. I've got quite a personal connection to this topic as well, as my grandma sadly passed away from ovarian cancer right before I was born, and due to chemoresistance as well, since the chemotherapy didn't work. My mother always loved to talk about her, and she seemed like an amazing woman. I wish I could have met her. She also told me about how difficult the chemotherapy process was for her and the family. So it's very important to me to do this research and help others as a result. So I came across the Big C after just having a chat with my lecturer after one of our workshops. I had a read of some of his papers online. I thought they were quite interesting. So I told him I was interested in pursuing a career in medicinal chemistry, and I was quite interested about cancer research. So we sat down, and he told me that I could apply for a summer placement with the Big C. That was also when I found out about the Lilac Ladies. I was inspired by how much good they had done for the community and the positive impact they'd had on the lives of so many people. I was thinking how lucky I would be to have my application picked by them. I'm just so grateful to have this opportunity, and I thank them and the Big C so much for allowing me to have this experience.